Today I'm going to start with the fourth unit. The fourth unit is dealing with sequential circuit. Okay, already I provide an introduction about the sequential circuit. So once again I'm going to recall it. So how the sequential circuit should be appear in the sense, okay, the combination circuit along with the memory element. Okay, this is a combination circuit. Okay, already we discussed that what are the operations are done by combination circuit. We can able to perform full order addition, subtraction. We can able to perform encoding, decoding. So these are the operations done by combination circuit. And then along with the combination circuit, what happened? It added with the memory element. So memory element. So memory element. Okay. This is a feedback for your system. This is called as a sequential circuit. Sir, what you are trying to convey in the sense sequential circuit diagram. So what I am trying to convey in the sense, okay, the first observation is the sequential circuit is the sequential circuit. It's a combinational circuit plus memory element. Combinational circuit plus memory element. Memory element. And second observation is suppose that sequential circuit is going to produce a current output. The current output, it's depending on the current output depends on its current output depends on, okay, the current input value as well as it's a depend on current input values as well as okay the output value previous output value. Okay, for example, the first instant, for example, I equal to 0, what happened? I'm passing input for that sequential circuit. Okay, if we consider here, what happened? It going to produce output as well as so what is the current output? It could be stored on one memory element. Okay, it could be stored on the memory element. Suppose the next instant time, whenever the I equal to 1, so what it going to do? I'm going to passing certain input. For example, I'm passing input as a 1. So what happened? So whenever suppose what happens, sir? Whenever the next time, whenever I'm going to provide input, what happened? So what are the okay? Whenever I provide the next time input, what happens, sir? Here two inputs are there. Here this is a 1. This is a 1 here. So what information is available here in the sense previous value is stored in the memory element. Okay, this is the input for next stage. So what I'm trying to say that whenever it's going to produce a current output, it's depending on current input as well as the previous output. The previous output we stored on the memory element. So that's why the people saying that whenever the sequential circuit is going to generate the current output, it depending on current input as well as previous output. Okay. Okay. Before move on to that, what are the different types of sequential circuit? I will talk about what is a clock. Okay. 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 What is a clock? Okay. The here, in order to generate the clock signal, what happened? We are using for clock generator. So in order to generate the clock signal, what happened? We are using for clock generator. Okay. So what is the duty of the clock generator in the sense to generate, generate the clock signal. Generate the clock signal. Okay. Okay. I will show you how the clock signal should be appear. Okay. It should be appear like that. Okay. It should be appear like that. Okay. It should be appear like that. Okay, people, this one is called as a 1, this one is called as a 0. Okay, whenever Okay, trigger up level is there, people call it as a 1, and down level we call it as a denoted as a 0. Okay, what is the use of clock signal in the sense? Make use of make use of the clock signal to control the sequential circuit. To control the sequential circuit. That's why we are using for clock signal. Okay, suppose I'm using clock signal to control the sequential circuit. That circuit people call as synchronous sequential circuit. Synchronous sequential circuit. Synchronous sequential circuit. Okay. Okay. First, I will defining how the clock should be appear. Okay, this is the way the clock should be appear. Who is going to generate the clock in the sense? Clock generator. One of the hardware devices are available. Make use of that. What happen? It will generate the clock signal. So, what is the necessity of the clock signal in the sense? It will control the sequential circuit. For example, I will show it in diagrammatic way. For example, here how the sequential circuit is appear. Combination circuit. The combinational. Okay, what happened? So it produces two output. One is output, another one is what happened? It will store on the memory element. This is a memory element. Okay, this is a feedback for my circuit. This is a feedback my circuit. Along with the memory element, what happened? It had one more input. That input is called as a clock. The input is called as a clock. So if it is there, the type of circuit we call it as synchronous synchronous sequential circuit. Synchronous sequential circuit. Okay. The next category is okay. Okay, this is a synchronous sequential circuit. Okay. So based on the clock signal, that synchronous the sequential circuit is divided into two categories. Sequential circuit. So divided into two categories. One is called as a synchronous sequential circuit. Synchronous sequential circuit. Another one is called as asynchronous sequential circuit. Asynchronous sequential circuit. Asynchronous sequential circuit. Sequential circuit. So already I said as synchronous in the sense what happened? Okay. So one of the parameter is a clock. So make use of that what happened? We control entire sequential circuit. Okay. Entire sequential circuit. How the clock should be appear? It should be appear like that. It should be appear like that. How we are going to generate the clock? Make use of clock generator. So whenever the clock value equal to Z1 in the sense what happened? So it operate. So it will operate. That's the sequential circuit. It operates that sequential circuit. So whenever the clock value equal to 0, what happen? The clock value equal to 0, what happen? Okay, it does not, no operation. Okay, this is a way what happen, it will control that sequential circuit. Okay, this is a way what happen, it will control that sequential circuit. Okay, okay, if we go for asynchronous in the sense, there is no clock signal. So otherwise that asynchronous sequential circuit we call it as uncontrollable. We don't know how it's going to behave for particular time. If we go for the synchronous clock sequential circuit, whenever the clock signal is 1, I can defining that it's going to operate and then produce output. Whenever the clock value equal to 0, what happens? It does not perform any operation. If you go for asynchronous, there is no concept of control. So how it's going to behave in the sense uncontrollable form. Okay. So uncontrollable format. What it's trying to say that we do not know how it's going to behave. Okay, we do not know. Okay, how to behave particular movement. Okay, how to behave particular movement. Okay, okay. There is a classification of synchronous and asynchronous clock circuit. Okay, so do you have any queries? Do you have any queries?
No, sir.
No, sir.
Then next we are talk about that memory element. Okay, already I said the sequential circuit is the combination of combination circuit plus memory element. Okay, how we are going to implement that memory element. Okay, next we talk about so what is the memory element, how it should be appear. Okay, okay, memory element. So already we talked about that the sequential circuit is how we are going to implement in the sense it's a combination of combinational circuit as well as the memory element circuit as well as the memory element. Okay, memory element. Okay. Okay, next we are talked about how they are implemented that memory element. So for that, what are the different components they are going to use? Okay, first I will defining the what is a memory element. The memory element is okay. It is a remember is a memory element. It's a remember one unit of information. One unit of or one bit of one unit or one bit, both are same meaning, one bit of information. That is called as a memory element. Okay, we are implementing the memory element using two ways. One is called as a latches, another one is called as a flip flop. Another one is called as a flip flop. Okay, so both of them are acting as a memory. Okay, okay, we are implementing the memory element using two ways. One is called as a latches, another one is called as a flip flop. Okay, first we are initiate with what is a latch. Okay, what is the structure of latches? Okay, latch otherwise called as a memory element. Okay, so first I'm going to begin with the latch. Okay, what is the use of latch in the sense? Remember, remember one unit of information. One unit of remember one unit of information. That is called as a latch. Okay, so so different type of latches are available. Let me talk about one by one. The first latch we call it as SR latch. Okay, so different type of latch memory elements are available. The first one is called as a SR latch. Okay, um, okay. So so I will first I'm going to draw the circuit diagram of SR latch. Okay, this is called as a so this is a circuit diagram for SR latch. This is called as a NOR gate. This is called as a NOR gate. So what happened? It going to produce a two output. One is called as a Q, another one is called as a Q bar. Okay. So first I will talk about what is a behavior of NAND gate. Sorry, NOR gate. So what is the truth table of OR gate? What is the truth table? A, B, F, A, B, F. Okay. If any one of the input value equal to 1, what happens? The output equal to 1. Okay, any one of the input combination is 1, the output value equal to 1. So what about NOR gate? The NOR gate is just opposite of OR gate. Okay, what is the behavior? Okay, A, B, F. Okay, it is just opposite. Okay, whenever the both inputs are zero, then only what happen? It's going to put its output equal to one. The rest of the cases output equal to zero. The rest of the cases, output equal to zero. Okay, you should remember this truth table. Okay, okay. So now what I'm going to do? Okay, now what I'm going to do? Here, two variable. Here, how many variable input variables are available? Only two variable. One is called as or, another one is called as s. If the two variable in the sense, how many input combinations are available? 0, 0, 0, 1, 1, 0, and then 1. Okay. Okay. So first what I'm going to do initially, I'm going to take, r equal to 1. Okay. Here what I'm going to do, I'm going to take this input combination in random order. Okay. You can take any order. Okay. So first what I'm going to do, I'm take the input combination r equal to 1, s equal to 0. Okay. Now I'm going to check what is the behavior of that circuit. Okay. How the circuit should be appear. Okay. Or gate, or gate. Okay, one more here, one more OR gates are available. Sorry, in OR gate. Okay, this is a okay. So this is a R, this is a S. Okay, what is the value of R? R equal to 1 and then S equal to 0. Okay. 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 From this truth table, we are going to infer one information. So what information you are going to infer? Okay. If any one of the input values, for example, if any one of the input value equal to 1, definitely you may get output equal to 0. Okay. Here the one is there, definitely we got the output equal to 0. Similarly, consider this combination. Here one is there, definitely I will got the output equal to 0. Similarly, what happened here, both of the input combination 1, so definitely I will get the output equal to 0. So based on the observation, what I'm going to do, here what happens, sir, here r value equal to 0. So irrespective of another input, definitely this NOR gate, what it going to do, it going to generate output equal to 0. Okay, it's okay for you? Hello.
Yes, sir.
Okay. For example, here R value equal to 1, irrespective of another input, definitely the NOR gate is going to generate output equal to 0. Okay, this is the input for here. Okay, here. Okay, what happens, sir? S equal to 0, and then here the feedback value is also 0. Look at the NOR table. What happens, sir? Whenever the both input combination is 0, what happens? It generates the output equal to 1. Okay, it generates the output equal to 1. So based on that, what happened? Okay, what happened? Okay, I'm going to write the behavior of SR gate. Okay, I'm going to write the behavior of SR gate, SR latches in the truth table format. The truth table format. Okay, so you try to generate the two output. Try to generate the two output. So one is called as a Q, another one is called as a Q bar. Okay. Here, what is the input combination? 1, 1, R value equal to 1, and then S value equal to 0. What happens, sir? So this is called as a Q, this is called as a Q bar. Okay. This is a Q equal to 0, and then this one is a 1. Okay. It is okay for you? It is okay for you? Hello?
Yes, sir.
Okay. The next what I'm going to do, I'm taking next input combination. and then I'm going to predict what is the behavior of SR latches. The next input combination is I'm taking R equal to 0, R equal to 0, and then S equal to 1, S equal to 1. Now I'm going to try to predict the behavior of SR flip flop. Okay, now try to predict the behavior of SR flip flop. Okay, this is called as a R, this is called as a S. Okay, so R value equal to 0 and then 1 value equal to 1. So already we have infer one information. If any one of the big value equal to 1, definitely the NOR gate is produce the output value equal to 0. Okay, so definitely here what happened? Definitely it will produce output equal to 0. This is called as a Q naught. So this is the input for here. Here what happened? The Q value equal to 1. Okay, here what happened? The R value equal to 0 and then S value equal to 1. What happened? Okay, Q value equal to 1 and Q naught value equal to 0. Okay, it's okay for you? It's okay for you?
Yes, sir.
Yes, sir.
Okay. Okay. So next what happened? I will take another input. So another input combination is R equal to 0 and S equal to 0. R equal to 0 and then S equal to 0. I try to predict. I try to predict. I try to predict. Uh, in that I will try to predict the output. Okay. Let's see. Okay. Okay. Sir, here previously what happened, sir? Any one of the input combination is one, so we can easily predict that output. If we consider these cases, what happened? So both the inputs are zero. If it is there, what happened? Okay, okay, you look into that the past output value. Okay, 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 listen இங்க பாரு. முன்னாடி என்னாச்சுன்னா ஏதோ ஒரு இன்புட் காம்பினேஷன் என்ன ஆகும் அப்படின்னா ஒன்னு இருக்கும் அதனால we can easily predict the output. Here what happened? Both the inputs are zero. அப்படின்னா I am unable to predict the output. If it is there அப்படின்னா என்ன பண்றோம் அப்படின்னா so what is the previous input combination and then what is the output? So previous input combination is a 0 1. The output is called as a q value equal to 1 and then q naught value equal to 0. Am I correct? Okay, so based on that what happened, you want to work it out. Okay, now what I'm going to do, I'm going to take this one. Okay, now what happened, I'm going to take this one. So uh, okay, now previous stage output எடுத்துக்கிறேன் q equal to 1 and then q not equal to 0 அதை எடுத்துக்கிறேன். So நான் என்ன பண்றேன் அப்படின்னு பாத்தீங்கன்னா the q is a input for this NOR gate. The Q is the input for this NOR gate. So what happens, sir? 0 1 combination. So 0 1 combination is definitely the output value equal to 0. Definitely the output value equal to 0. Okay, this is a feedback for this NOR gate. This is a feedback for this NOR gate. So what happens, sir? 0 0. So 0 0 0 means what is the output value? 1. So based on that, what happened? I'm going to predict the behavior of this SR gate, SR latch. Okay, what is the output? So both the input combination is zero in the sense the Q value equal to 1 and then Q naught value equal to Q bar value equal to 0. Okay, it's okay for you? Hello? This is okay for you?
Yes, sir.
Okay.
Yes, sir.
So next I'm taking another input combination. Okay. So what is the next another input combination in the sense 0 0 0. Okay, I will change the order. Actually, okay. Okay, actually, I did one mistake. So, okay, in your everything is fine, but we provide the input combination in a different order. Okay, that makes some sense. Okay, so how we are going to provide input in the sense? Okay, first input combination is okay. Next, what we are going to do? Okay, we are providing the input r equal to 0 and s equal to 0. So now we are going to uh, okay, if s equal to 0 and r equal to 0, okay, so now we want to predict the behavior of SR flip-flop. So now what we are going to do, we are going to provide input combination is 0 0. So now what happened, we are going to predict the behavior of SR flip-flops. But here there is no clue. If any one of the input combination is one in the sense, definitely we can predict the behavior of NOR gate. But here the both the inputs are zero. So in these cases, what happened? So you take the previous stage out. What is the previous stage output? The Q equal to zero, and then Q bar equal to one. Am I correct? So so this is the input for S gate. The Q is the input for S gate. What happens, sir? So 0 0. Okay. Okay, the rest of the things we will see next class. Okay, thank you so much. Okay. So I will take the attendance. Okay, thank you so much. Gosh, gosh.